The following presentation was recorded at the 2012 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2012 for helping make these videos possible.
Good evening and welcome to SouthEast LinuxFest 2012. This session we're going to have Keith Larson from Oracle. He's going to be talking to us about summary tables.
Thank you very much. Can everybody hear me? Is this way too loud? You good? Make sure. All right. So I realize this talk is the very end of a long day. So trust me, the goal of this is to give you some information, let you ask yourself some questions on how you want to proceed with things, but also to have fun. So, first and foremost, don't believe anything I say, because lawyers won't back me up later. So, if you've seen any of our Oracle presentations, which I've seen you have today, this is just the quick blurb of everything we talk about is feature release, but mine's more theory, so it doesn't really matter. But who am I? I'm a community manager for MySQL. I've started with MySQL back around the 3.23 days, and a lot of my work has primarily been with a marketing company that did a lot of, had an ODB MySQL representation with delayed replication. And what we did a lot of data mining, because marketing folks need to follow trends and find trends and want to detail every minute information. So we did a lot of digging and fine tuning. Now, with that, I kind of wrote a blog spot when I came on the MySQL side, which is here, which is originally started the spur for the abstract for this talk. So if you guys want to go see that, there's a whole examples and whatnot for that as well. But what I did for this talk is when I looked at the agenda, which is my original agenda, I was like, okay, well, let's just actually break this out in a little bit more a funner way and have more fun with it. So we're going to go through a little situation, some solutions to it, and then some resources to how to solve this situation. Now, we are at a Linux festival, so hopefully you guys all get the concept. You probably shouldn't have to read too much more to that to understand where this is from. I assume you're all Matrix fans. So the real question out of this is not the top one, but more of this one here is, are you asking the right questions when you approach your databases? Because a lot of people hear summary tables and materialized views and all this, and they think that that's the best solution. It's like, oh, I have to do faster, I have to do this. And that's not always the case. There's certainly a case, but it's not always the case. So this is to fine tune to make sure how you guys want to, how can you go forward and really benchmark and find out what's going on to find the best thing. So with that, do you know your own data? Is the biggest question when you have your data and you're dealing with your databases, is how well do you know it? A lot of people assume that this is, one factor is how to do things, but they realize that there's actually a whole other scope over here that actually that's where all the big tables are. We'll go through some table structures and whatnot to see how people kind of get carried away with some stuff at times. But the question is, well, the picture doesn't show it too well, but what if your data was as big as the matrix? What if you did have to have a database that held all that stuff so you could render out the matrix for that in that example? How would you sort data efficiently? How would you define and data mine all that information, all the users, an example, and et cetera? How would you report trends if you were in that scope to have a data space that size? It's a lot of data if you actually think back to the movie structure. Speaking of structures, if you did have to have a database, you might start off with and tailor all the people and all the scopes of a matrix type environment. You would start off with just the big towers that they have all the pods in. You might have information like the structure IDs on that long so you know where they are. You might have dates that came online, how many levels are in them, how many maximum pods would fit on those structures, what IP it might be, protocol information. There's numerous amounts of information that people gather when they start building different situations. Now, do you need all this information all the time? No. But sometimes you're going to tie this information to do data mining and dig into this stuff. So this might become relevant. You have to make sure you're keeping your tables with information you actually need. Now this isn't a summary table, but this is a scope of where you're going to start. Where you're going to start beginning. One note, just as because it comes up a lot, is IP, for example. A lot of people put in bar charts sometimes for IPs, or they put in these humongous integers. It's like, you don't need that. This is, I have examples in select statements. We'll touch base when you see it later. But this is actually a faster way to store IPs is this structure here. And again, do what?
How does that handle IPv6?
Oh, that's not for IPv6 though. That wouldn't be for that. So next case is once you've had your table for the structures, you're going to have all your data on all the pods that hold all these people. And you're like, okay, now we have a whole other realm of scopes and information that you all of a sudden you would need and you would keep track of. Again, you're going to know where is that pod? What structure is that pod in? You have a structure ID. When did it go online? When did it go offline? What level of the structure is it in? Positions, and again, etc. for IP communication, etc. All of this is a whole another realm of data that we end up in our databases in this theoretical environment that we realize that we might need one day, but then if you start data mining, it's going to get bigger and bigger and bigger. And of course, the real situation is when we get our neos, all the people that live in these worlds. You have to have humans, you might have a key to reference them, what pod are they in, and then you have to realize well, that's just who they are, but what about them? There's a whole structure of worlds of information that we might start digging into the actual people that are there. For example, his hair color, his first name, his last name, his gender, his address. All of a sudden, our data starts growing and growing and growing. Now, in this example, this is a simple concept of where we're going to build a data table. So we're going to have a table of, this is the questions we're going to ask about the human in this case. And you might tie that to a table that has the data about them. So now we know that Thomas Anderson lives in Chicago on West Addison Street, and he's in lower downtown because that's where he went to high school, I believe it was, junior high school, and he was in Patterson High School. So we have this full set of this one person. Now this is an easy, simple query for just one guy. But if you're going to start data mining the world of the matrix, it's going to get bigger and bigger and bigger. And of course, what else are you going to ask about this guy? You might have a job table. What salary does he make? What kind of salary, what title does he have? What color is his hair? Or do you want to break that out into hair color? Or you want to leave a table separated for just color in general so you can reference it again? All of a sudden, again, tables start growing and growing and growing, and you're going to need a data mine and conglomerate all this data together. Again, eye color. Maybe he has shapes of eyes. It might have eyes for cats. What species is he? Who knows what kind of data you guys start tying things together. Same thing with hair. You never know how you're going to grow. So all of a sudden, you've built something out, and you have this huge query just to find out a couple informations about this guy. And you're like, okay, great. And it's pretty quick. It's just one query. It's just one guy. You have it on human ID, so it's pretty quick to find them. It's pretty easy. But if you start data mining this, running this query for all kinds of people, it's going to take a while because you're joining and scanning the whole world here. Now, in relevance, that query just pulled up a simple general information about the guy in these structures of the world here. But in this case here, we have one that's you're scanning for lots of data. So now we're going to say, okay, well, what about you want to scan for a bigger range, and everybody has the name of, starts with MC. So all of a sudden now you're digging across a full scan that wasn't an index before. And you realize, okay, it was pretty quick. You pull a bunch of keys and datas, and you're pulling by gender, but this is an example of 1,400 rows. It's like, okay, that's a simple start. But my point here is, when we're going here, is how many knows what a snowflake table is? The snowflake schema. You're having tables all over the place, and it builds replication of a snowflake. Now that's always not what you want to do, and sometimes in the sense of you want to build that to the start if you're normalizing your data the best you can, but sometimes that's not always the best practice of you having speedy data in the sense of you need to get data faster. MySQL, for example, there was companies that went and took longer than 3 seconds to get a result, they basically considered that an outage. So sometimes snowflakes work fantastic. Sometimes you want to consolidate data to make sure it's faster. A lot of that is usually called data warehousing. You're starting to data warehouse the data and consolidate. Josh is actually giving the same talk tomorrow about data warehousing in this exact same location, same time, same place tomorrow. A simple concept of the data warehouse, though, is the large accumulated data in a wide range. There's different theories on how to, and the best way to use a data warehouse. Bill Lamons and Ralph Kimball's both have different realms of it. If you haven't seen either one, Ralph Kimball, for example, has a humongous stack of books that cover this topic. I'm more on the Ralph side of the world, just so you know. The summary table concept within that is basically the same as a materialized view. It's the same thing, the terms kind of go in and out, it's the same. But we're going to collect some of this data to make it easier to use. And if you're going to use this going forward, we're going to step through of how you can use this in ETL processes to have this in your system to aggregate data and make it easier to do. But at the same time, asking the question of, do you need this? So let's say we're going to build a table called the matrix. And it has, these are the top queries that the CEO and the marketing teams ask for out of this series. Now, when we build a matrix, or summary tables in this case, this does not have to be the only one. Just because you build a data warehouse or a summary table, there doesn't have to be one summary table. You have to summarize the data that you're asking, you're getting the most questions asked, and to speed the process along. In this case, these are the questions we are asked a lot. Now later on, if I'm coming in and there's 15 more questions, it might not be the best case to add 15 more columns to this. But take advantage of and do your research ahead of time to realize what questions you need to be asking and what can you consolidate to benefit from. And how many here know what an ETL process is? So, examples. Okay, good. So we're going to start with the extract and load process. Now, I didn't transform anything this way. I didn't put T in there in the middle of that. But this is a simple example of a stored procedure. And this is where I'm extracting the data from the query above, and I'm going to replace it into the matrix, for example. This is a simple concept of, I find out the last time the date ran for the matrix, so the max data I have in there, and I'm replacing data in there. And all of a sudden now I'm starting to gather data, but the question is now, it's like, okay, well, how, and I'm loading data, but how often and how do you get this to run? You're not going to sit there and click this all the time. You're going to run it with a shell script, you're going to run the Perl script. How do you want it to happen? We have events inside MySQL, which is basically the concept being of you can run it like an internal cron process, for lack of a better term. So in this case, we're building the matrix every 10 minutes. And you can, on schedule, run every 10 minutes and comment it for future use. It's always a good thing to do. In this case, we're calling build a matrix, which is the procedure I just built. You can start and stop this to check if it's been run in your system by showing the variables like events at _s, and it'll pull it right up. And you can see it's running. Just a brief example. So now that we have all this data running in our system, with the events are starting to build and gather data, we're like, okay, well, I can look at this, and I gathered from no cache, and I'm trying to count the data to find out who has, sorting by value of hair color and states and gender. Starting to find out, do a little data mine to see if there's any trends on if I'm in the matrix realm, am I building too many people in one spot versus the other, for example. Now we realized that this took 5 seconds. That would basically be an outage in some .com realms. So in this one, we're like, okay, well, if I pull that data from the matrix side of stuff, it only put 0.66 seconds. Okay, it's a lot faster, that's great. But something rolls a little bit different in this case. I'm chiming it a little bit different. Is it actually the best thing for me? So I joined it again, moving my data from the where, and all of a sudden what took 5, now it's only 14 seconds. It's actually faster than the first one, the second one. So in this case, is what I actually wanted the best way to dig in what I was actually after? It's more of, just because you write the query the first time one way, tear it apart and just test it a different way to make sure you're benchmarking your processes. Because a lot of times people will put some of this data in the where here up on the joins And that's not always going to actually lock it down. Of course, in this example, they very well left joined, so it wouldn't have locked it down very well anyway, which is why it took longer. There's also the process, and sometimes if you don't want to build a new table for everything, but sometimes you just want to build a view, which is a view into a table. It's kind of like a summary table. So in this case, we're going to create a view, matrix view, and we're just going to select the statement out of it and you drop it into here. Same data, just a different angle to pull it out of. This isn't always going to be as fresh of data though. You might have to execute this and run this a little bit more often. But you can populate the table and continue on. I mean, it still works. This is the case here where I have the same procedure, I believe, just to give you a reference point. So now again, we have our events. And we're going to go through and build the matrix every 2 minutes, and we're going to see this is how it actually look into the show events to see more data in the events. Oops. And if you want to dig in a little further to see even more data about events, you can go to information schema, and you get a full set of a lot more detailed information about the process of events and whatnot. How many people ever ran events or knew they even existed? All right, good. Because sometimes people never knew they ever ran. So it's like, okay, they're there. Something else that people run and often can use are triggers. I didn't build a trigger example out of this because I never ran them in this scope. But because of the scope, we're building in data mining a little bit differently. But this is a simple example of how we could build a trigger for those who've never built a trigger inside MySQL. If you wanted to pull one data, if you tuned your tables a little bit differently to every time someone changes eye color, for example, and you want to update if you change it from lowercase, from blue to violet or something, and you want to trigger it to change data, you could go through and set data like that. So transform data. ETL is the extract, transform, and load. So you need to realize what you want to do and how you want to do it. There's realms of, sometimes you want to normalize data a little bit differently. Sometimes you want to process this data or evaluate this data, third-party tools. There's a lot of, in our case, we did a lot of, with Perl scripts, we would pull data out, verify the user data via third-party tools, and transform that data back when we put it in, because we verified who was valid data, who wasn't, who put in false information, who didn't false in, who's valid emails versus invalid emails, stuff like that. You can define all your data and transform to your data after the fact and put that in summary tables to confirm knowledge base of what you want to do. Again, this goes back to knowing your data and how you want to proceed going forward. An example there was the script process. So on top of that, you have all this data, but then your CEOs come in and the marketing teams come in and they want to know more about the reporting. They need to build data. They want to know the numbers so they can process and get further with this. So in this case, we pick a little between 985 and 1998. We pull out just based on gender to know who do we have out there. And I'm also pulling this based on, if you notice, I'm tying in those pod structures and the structure itself and the pods. Now I'm using the matrix in one scope because I can gather a lot of data. And then I just want to toss in a couple of the tables to quickly rectify some solutions there. This one, however, took 2 seconds. Now, maybe we want to build out a structure table. You notice we have our data here. And we're going to start with the lowest common denominator because we're going to build processes in different tables to smaller summary tables. So we're going to start with the lowest common denominator, which we know this one is. Now, if we wanted to go just the last 24 hours, for example, we could have the same table and report into here just the last 24 hours. Notice by placing everything out, and we could build structures and more events to just keep that as just 24-hour tables. It would naturally be a very small tables, depending on in the scope of everything. And you could query this as a report, and you'd have data very fast for your CEOs and whatnot. How many have had CEOs that asked for year-long reports during demos, during peak times, when the database is halted in some way or another because a slave went down or something, and what you'd normally query off of here, you have a CEO's concept of a multi-million-dollar deal. If this one report runs, you're like, no, that's not really true. But I've been in that situation where they think the whole .com realm is going to not buy their system if they don't get this report done. building structures out so you can query faster and easier helps us and gives you summary tables to gather data quickly, is the concept behind that. Now this is just 24 hours, so we can continue on and say, okay, well now we want a 24-hour one, and we want to build a per day one too. So which is basically the last 24 hours, but this one we're going to keep. So you'll have a broken down per day. So we're not going to get rid of this data. This is just every day you'll give a new row, new data, and you'll have it easily transformed to use it. Now you can take this data as you go forward and build per month. As you see, structure per month, selecting from per day. And I did 2 months just to make sure we can easily pull it up. It runs every month or so, every couple of weeks, which is on my events later on. So the point being is that you can build off your tables and your data and keep summarizing that down. And if you wanted to go back and because you changed something in your initial table, your lowest common denominator table, you could simply run these procedures again and they would just build up on each other again. So fix your data, have it roll into your 24 hours or your day one, run it again for the same time frame for just your month data, and you easily compact all your data in different summary tables. Go ahead.
So the concept is to run a summary table once, and then you can query against that 100 times. It's much faster on such as one run. Mm-hmm. So it's still going to take a long time. The one time you run it.
When you build it, it's going to take a little bit. Okay. But everything after that is going to be cached. Some of this data is going to be cached. And then because I'm putting no cache in like select statements just to force it to be slower. Yeah. It's the slowest common denominator. But beyond that, then you can query this data really quick because you're not going to go digging off the last 2 months, for example, is a lot faster here because you.
You're not going to dig through the whole humans table in your example.
Exactly. To count everybody, it's all right here really quick. So then, for example, we did this per month. Now let's do it for a year. So now these are tied to the questions with the CEO, for example, or marketing when I might be asking. These are questions based off, we need to know amounts, genders, and date online. And that very simple first example I gave. In this scope again, we're querying off our per month table to build the year data. And we might easily pull off and query data off multiple years in our corporation to give these numbers, and we can tell our CEOs and whoever or not breakouts of genders and ages, who we had in our system per year very fast because we've calculated and consolidated this data over time. You went back to the human table to break all that down and group by years, and you're trying to insert data into the same table or replicate data, and you're selecting big locks off of it, you're going to slow some systems down. This way you can do it small, quickly, and you have full sets of data that you can easily use for your purposes later.
So once you build a table for, say, February, you don't have to rebuild that table for February again. You're always building for the current month.
Yeah, just keep going. Breaks it all out. So in this scope, here's the basic ways a lot of this stuff was built, for example. We have our reporting per day. It goes back and replace into this table, simple event to build it per day. Again, these are the same scope per month. I go through and build it. Every 2 months, I'm going to go back and grab that data again. The concept being is that I go back over time to make sure of any changes. If somebody goes through that core data sets and has changed data, I'm always capturing the newest data to make sure it's fresh and up to date when I'm querying data over date ranges. Because there's times, if you did something where Sunday you did it for the last week, and then every Sunday you did it just for last week, well, what if somebody changed data that was a little bit earlier? And if it was a lot earlier, then they have to let you know as you can actually process data in different ways. But for this concept, if you build out your date update stamps and how you query the data initially, you should always have the scope of through fresh data, which is part of some of the initial queries of how it gathered, how I knew what was the most updated data. There's a procedure that has the date update if you wanted to reference it for examples later. So again, this is a simple concept per year. So all this scope here is basically built on a lot of stuff we actually did in the company I used to work for. We didn't have the matrix tables, but it was a marketing type scope of user data. And concepts like this have made it really easy to go through tables that we filled the maximum integer, for example, in the auto run commit. which is like billions of rows. We had over 4 billion rows easily in this one table of just user data, which was my initial example up front. We captured stuff for everybody. And there was numerous different ways that these reports were built out to summarize all this user data. It could have been everything from clothing type to gender to they smoked or if they, who knows what it was, all this marketing type data. But you could conglomerate this down and summarize it in different ways so you can ask the right questions to easily find out the best and fastest answer for you. Again, this is a theoretical, quick example of this, but just to give you a scope. Now, like I said before, I wanted to make sure you guys get out of here because you've been here all day. So, the quick example here is if you ask the right questions and your other DBA is, who do you want to be? Do you want to be the Matrix Neo or John Anderson? So who do you want your CEO to think you are is a better example in this case. So you can step in and you are the one to solve the problems. You are the one to have the best answers because it's very quick to find those answers because you've done the work in the past. If you want resources for this type of scope to actually dig in a lot deeper beyond talk tomorrow, this is Kimball's book that I talked about. He has a whole series of books. This high performance book. We have Pentaho and different solutions here, and all with links to go dig in for more information. And that's my quick example because I knew you guys wanted to get out of here tonight. So, any questions? It was a theoretical world example, but I want to take a little different approach. So, anything else? I can back up and show tables, whatnot. Anything you want to see? Go ahead. Views are, I mean, you can do views. I'm not saying you can't do views. You can still do views in ETL processes to populate them. I'm just saying just because you build a view once doesn't mean that you're done with it. Because you want to build and process some of this data. For example, the 24-hour table I built versus the day table was also a memory engine, which means if the database crashed, you'd lose all that information. You just build it back up again. But you were fine with it. It's easy to build again. It's just 24 hours. The day one was an engine because you're going to store that to the disk itself. Different types of engines, you can pull data faster and use this data a lot more easier. In the views case, it was a set build. We built off that query, so only that one set of data. And you could build a view if you wanted to. In this example, it was just actually slower than using the database engine and the memory engine. In that example I built was why I showed the differences. Just because to ask the question to find out, is it faster to use a view or is it not? Sometimes it is. It's just a matter of to ask the right questions, to dig in, to really find out if it's which one to use. It was the concept there. Anything else?
I didn't catch much about what you were talking about transforming the data. Like, how are you transforming things? Are you using some kind of external script?
It depends on what you want. It's a case of what you need to do. A lot of times if you're just summarizing, you're just extracting, you're loading data. If you need to transform data in different ways, like let's say you have a website and you're capturing gender, and you build it and you have a whole team of developers that let people input data. So you might have female, you might have male, you might have capital M, you might have capital F, you might have lowercase m and lowercase f. You have a whole set of data that you need to actually know is it just male or female. So in that scope, you might be like, okay, well now I'm going to select data out of this set. I'm going to look it over and conglomerate, maybe you have a case statement to find all these different cases and just equals M or F, capitals, whatever you wanted to do, and you set that into your database. And now you've actually gathered the scope of data, you've summarized it into normalized it in the scope of you actually know what it is, and you've transformed the actual data into a way that you're going to actually use it better later.
More complicated, like validating an address that you can't do within MySQL.
That would do a third party. That's a third party example. Or you might have a Perl script, for example, or a Python script or something that queries a bunch of tables and then counts them and finds it and then inserts again. We did a lot of that in the scope of like validating email addresses or something. And we queried this data and we found out this email address was 6 months old. This email address is 2 weeks old, something like that. Is it valid? Do you not care about it? Different scopes like that. Use third party tools, for example. Anything more? Like I said, it was a little. I want to take a different approach, a little different, but good.
I have a question, but I don't want to tag it right now.
It's open.
One of the things that we keep track of is uniques.
Sure.
So I can summarize those into
Unique users, is that what
specific time periods, easily
Okay.
enough.
Okay.
But when they pull the report, there's a total one, and all of the other information I can just add it up from the summaries. But on the uniques, that means I have to go back to the original table and run a distinct account on the original data set.
Mm-hmm.
Is there a way for me to not have to do that?
Well, let me,
Some sort of way to represent the uniques in a way that they can be summed together? If it was a small
Let me-
number, then I'd say something like a bit mask.
sure.
But if I'm talking about, the uniques could be up in millions, then the bit mask really won't work.
So I'll repeat the question, sure I understood that question and for the video as well. So you're looking for, how can you summarize unique users? Is it users or is it,
And it's listeners.
or entities?
but
Okay, unique users or entities in a way that you're gonna have numerous non-unique data, but you wanna be able to count unique users out of it. Is that basically correct? How do you summarize it when you can summarize non-unique and totals, but you want unique users in a simple, easy way?
Well, I can summarize daily uniques.
Oh, okay.
And then I can pull, if I need the uniques for the month, then I already
Sure.
have those summarized by day. But
Counted by
I also
month.
need a unique for the entire month. Now, I can't summarize that because I don't know what the period is. It could be the last 7 days, it could be over the last 6 months. That total time period could vary.
So a table of, if you're doing it per day, if you don't know if you're going to need it per day or per week, so you want to build that table, but you can calculate it up. You can build a different table. You can build your scope of just the daily counts, for example. And you can always count and date format that pretty quick if it was just 6 months or longer. If you wanted to do that in a way that it was only unique, you might have a totals and then a same version of just unique totals per day. And those tables should be relatively small and just your counts. And it should be fast to query if you're just summarizing off those rows.
Right, but for me to get the number of uniques for the last year, then I have to go back to the.
You should be able to count your uniques by year, by 30. What's the last 365 days?
Well,
Which should be
30
telling
uniques
us.
yesterday and 25 uniques today does not make 55 uniques.
Oh, per user. Okay, you're talking about across different days, not just per day. Okay. Yeah, that had to be a little digging on your tables to see what would be unique overall. But in this example and how we used to do something like that, we actually broke it out we could count per unique user ID as they came in. One table had just uniques, so we always knew where they were and a timestamp on that, so we knew when they were there. So we could just count off that one scope. So your initial, like you might have a user ID table, and then like a scope of users, sessions, or entities, whatever they might want to do. If you timestamped that user ID when they first entered them, you would always know when they were there. You maybe have a timestamp when they were last there, how you wanted to count them. Whatever data you might need. You can reference that one table to easily count some of that stuff if you had to dig a little bit deeper. If you're doing something like that, which is different than this, if you don't know, that's where sometimes you have to dig all the way down to your granular data. And that might be a case where, you want to build a bot that runs overnight, and then you're going to see that and realize how can I build a different table. But I have to see your data to know to know the right question to ask and tell me how you really want to go. But it is, sometimes the CEO wants unique users across the last 6 years, and you're like, well, that's going to take a while. But that's the case where maybe you can build an event that just does it, a set of users. Yeah, then it's a little harder.
It's kind of on demand. They're asking for it, and
So there's the scope of, we had a lot of data where it was people coming in, and I gathered, like, example, their gender and their hair color and all that type of stuff across the front end. So we knew when they last here, what the questions they were coming in, and when they were last dated, when they initially came in, and when they last came in. So if it's a case where you can realize you had some general scope of it, and they came back through, you could go, okay, well, this is when they were first here, they were first unique at this date, and they were last here then, so maybe they might be able to help. But you would always do a replace into that table. If you updated anything, so you still always have your unique first date was always set. So if you had to count, how long ago did somebody come in, or you had to scope it out. Again, it depends on some of the questions you're asking in your data. I just see the architecture scheme of it actually to think, okay, that's this and this and this, but it's not an exact easy question.
When they created, you put a date, the last time you were there, you put a date, you want to find it.
The difference.
Say if it was prior to this date, was the first time they were there, and before.
Was the last time they were there. And now in that sense too, but there's the questions like, okay, I want to know every time they were here. And that's like a session table. You go, okay, there's always here. You count off of
They
it.
came in this time, the last time they were here was this time, and they've been here this many times.
It is. There's a lot of, we had a lot of issues with the dates and tracking users. And then one of those scenarios it was exactly that were they here 6 months ago? If you just do replace it all the time on just a session table, for example, it's like, well, they were here just once, did you replace their session? Or no, actually you add another session into it. So you have all their user IDs and their session IDs, for example, and that's a big scope. So you have every time they were there. But you're going to count a lot of that stuff a lot. So in that scope, you're going to break it out and however you want to partition that out or query that a little bit differently to make that a little bit easier to do. At the same time, I'm trying to think if partitioning would make an easy way to break down some of your data to make it easier to dig into, but that would be by date, not by user though. So.
And even what constitutes unique is changing.
That makes it even harder, yeah.
Well, right now we're using IP address as unique, and that's not signified unique. So
Yeah, the same user could go listen to the car or listen to it in the home and have different IP address, but it's actually the same user.
or if it's from a workplace, it could be 8 different people showing up with one IP address.
Yeah, that might be I don't know the data points that you have coming in to maybe define it a little bit differently to make it a little bit easier way to track it, but I don't know. You can email me, I'll try to help you out, but.
Sources, and it's a mess. I just don't want to go through and count. I have to have it scanned through
Billions of rows, yeah.
rows
Yeah, exactly.
to come up with
One unique row.
Another approach might be to do the smallest time period they might actually ask for, like by day, and summarize it every day and just say, this many.
No, we do that. Like, okay, what they will do is they will say, I want to see the stats for the last month. And we'll give them a daily granularity. So we'll give them, for each day, these were the unique listeners. They listened for an average of this long, blah, blah, blah. And that's easy enough. And because the time periods are set, midnight to midnight, I can summarize that. And I've summarized that into a different table. But then at the bottom, there's total. How many unique listeners did we have for the last 30 days?
So let me ask
I can't summarize this
Have
out.
the actual user ID in it, though. You're just having.
Yeah, so let me ask you this question then. Could you build into a row in the summary table that had a unique users and non-unique users in it, maybe for example, per day? So you could always do a count, and when you did a count, you knew if the user was coming back or not. So when you insert into that table, you know at that point if they've been here before or not, because you have a user ID or not. So you flag that data. Maybe it's 15 people today of non-unique and 15 people that are unique. So you can count those data. If you depend on what you know, you can decide, for this day, don't count non-unique so they've been here before. Only give me non-unique data, which would be your full scope of people who are just unique users. Because you broke the data out and you already knew.
So I would, besides the
You would
uniques, I would also have a column of new.
Or I would do counts across, so I knew how many people had came back that day of new users and how many were duplicate users. So if you're just doing a count, you can break it off and decide what type of data you want. How many were there total that year, and how many people were brand new that year within the same table. You just didn't count uniques or not, because they came back or they didn't. You don't care, it's up to you.
That's interesting.
It's a matter of how you separate it out. It's on the fly, me thinking about it right here. So it's a matter of just looking at the data.
What I was looking for is I've heard that there are structures for okay, if you have only 10 users and you want to know how many of them showed up today. Or you keep track of how many of them showed up. And then you can set a bit, you know, and a number for each user.
Sure.
And then if you want to sum those up and keep the unique correct, you just OR them all together, and then you do a bit count on the final, right?
You're talking about summarizing the count, yeah.
And I'm looking for something that's similar to that, but that can handle, you know, a couple million
Sure.
population count.
And that's, in the concept of that summary, I think you might get that. You just summarize your totals of the data you gathered, so you broke it out in how you don't know. Because I mean, am I correct in saying that your boss or whoever might say, I need to know how many people were here the last year, and then come back and say, okay, how many people were here that were unique the last year? Is that correct?
Well,
See, I'd like this to be more of a boss style. We can all figure that out, so it's good. Because everybody has problems like this. So.
Clients, but,
Oh, okay.
They would say they would want to know the stats for from a start date to an end date.
Sure.
The start date and end dates are variable.
Yeah, they have a commercial, for example, and they want to listen to how many people listen to my commercial across these date ranges when they ran. Is it?
Pretty much exactly that question.
Okay.
And we.
So you have an entity ID for your commercial.
How many listened to it on each day, and then how many people heard it over the entire month.
Sure. That concept could do that then. You have a commercial ID, you have date ranges, you have counts per, either unique counts per that day and then just total counts per that day. So if you would just wipe out.
Yeah, I'm not clear on how I can get the.
Email me some scope and I'll type it up and send it back to you. It's a concept of it. Maybe that'll help. Maybe a little. I don't care. Do it. I'll give it to you.
It is the one thing that's killing.
See, I wish I had a whiteboard. I'd be like drawing all over things, but you know, I'd be like, here we go. Yeah, no, I was like, whiteboards, go on.
I think you just get a marker right.
I know, right on here. But that's the concept of it. I have it in my head of what I'm thinking of immediately, but yeah, no, email me. I have a card here somewhere. Yeah. Oh, cool. So any other questions? I mean, everybody has data and everybody has to like dig it, and your data is this big one day and it's going to be this big later. So you know, make sure you can define it the best way you can get the answers that you think you're going to get me later. So anything else? Any other questions? Come on, it's got to be something. No? All right, cool. Well, thanks. That's quick.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source.
The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how Cloud Stack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of Cloud Stack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you will you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
Cloud Stack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and Cloud Stack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on Cloud Stack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
Cloud Stack Management Server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using Cloud Stack. They were using it to transcode video. And I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.